All right, good morning. Today in class, we went over 5 problems just to kind of review. So if you weren't here, you can go ahead and watch this video, see which 5 we did. It's kind of a review of some stuff we did in chapter 4 a long time ago, back in week 1 or 2 of the semester, okay? So go ahead and pull out your notes, look through it, see if you can find some things that'll help you. I believe this first one was from 4.2. It says find the value of the sine of A. First thing we need to identify is A is over here. Meanwhile, sine, remember SOHCAHTOA, so that's O over H. Now if we look, our H is right here, the square root of 13. Our O would be 3. So 3 over square root of 13, and we're done. Except we have a square root on the bottom, and we want to rationalize the denominator so that the square root is not on the bottom. That's kind of improper form. So we multiply by the square root of 13 over the square root of 13. It's really like multiplying by 1, so it doesn't actually change it, just changes how it looks. And we'll get 3 square root of 13 over 13. Check if 3 goes into 13. It doesn't. Check if square root of 13 can be reduced. It can't. So we are done. Here, let me fix that box. So 3 square root of 13 over 13. All right. Question 2. If theta is an angle in standard position and its terminal side passes through the point -35, -12, find the exact value of cosecant theta in simplest radical form. Okay, so we start off, if we have our coordinates, -35, 12 is going to be left 35 down 12. So -35 goes there, -12 goes there. The theta is always right by the origin, so it'll be there. Now it asks us to find the exact value of cosecant. Remember, cosecant is the reciprocal of sine. So sine, so O over H. So cosecant will be H over O. Hopefully you see that we know the O already is -12. H we don't know though. So let's go ahead and solve for H. We can use Pythagorean theorem because it is a right triangle. Okay, so -12 squared plus -35 squared. All of that gives us whatever x squared is. So we get 144 here. And remember, negative times a negative is positive. If you don't have -35 squared memorized, that's okay. 35 raised to the second, 1225. So then we add those two together, and we'll get 1369. Take the square root of both of those to find what x is. The square root, we can just do second, hit that x squared of 1369, and we hit enter, and we'll get 37. So we can put that as our h, and at this point now, all we have to do is write h over o, so 37 over -12, we are done. Now, if at any point you're not understanding, look back through the notes, even look at the lessons from, I think this was also 4.2 or maybe 4.3. So this next one here, given that theta equals -12 over 5 and theta is in quadrant 4, find the exact value of cosine. Okay, so once again, we know cosine A over H, ca, and if we have quadrant 4, that's down to the right, so we know it's going to be somewhere to the right. We don't know exactly what it's going to look like yet, but we know it's somewhere over here. So if we think about it, tangent, TOA, this is O, this is A. Now, compared to theta, O is on this side. So O is down. Down is negative, so that negative has to go with the -12. Meanwhile, 5 is the adjacent, and 5 is to the right. That's positive, so it makes sense that that was positive. And we need to find what the hypotenuse is, what this is. We'll use the same method as the last one. 5 squared plus whatever -12 squared is will equal x squared. 25 plus 144. If we get all that, we'll get x squared. 169 equals x squared. Take the square root, x equals 13. Almost done. Now all we got to do, a over h, so a is 5, 13 is h, and we are done. On to the next one. 2 more to do. It says what quadrant is, and then there's some situations. So remember back, I believe this was on the back side of 4.3, we talked about, we have our 4 quadrants, okay? In quadrant 1, there's our sine, our cosine, and our tangent, and we said that all of them are positive in quadrant 1. And if we think about it, not everything's listed here, sine, cosine, tangent, but we are missing secant. Secant matches up with cosine. Cosecant, that matches up with sine. Cotangent, that matches up with tangent. And when I say match up, I mean they are the reciprocals. If we take the reciprocal of something, the sign will not change. So not only are sine, cosine, and tangent positive, but also cosecant, secant, and cotangent are also positive. So, meanwhile, in quadrant 2, sine is still positive, cosine, though, is now negative, and as a result, tangent is also negative. If you're not sure how we got these, we could draw triangles in each of these, but for now, just take my word, okay? If you want to see it in more detail, talk to me and I can draw the triangles for you, or go back to lesson 4.3. So next, quadrant 3, sine is negative now, cosine is still negative, tangent is positive. And then finally, quadrant 4, this one is sine is still negative, cosine is now positive, and tangent is negative. So if we look here at our 3 examples, example A, sine is greater than 0, that means it is positive. Secant, which is the same as cosine, is less than 0, so that's negative. So we look, where is sine positive? So it'd have to either be 1 or 2, and cosine negative, so quadrant 2. And that is our answer. Next one, cosine is less than 0, so that's negative. Tangent's less than 0, that's negative. Where is both cosine and the tangent negative? Over here in quadrant 2. Next one, cosine is positive, so it has to be either 1 or 4. The cosecant, that one matches up with sine, is also positive. They're both positive in quadrant 1. All right. And the final review question we did today is right here, and I made a little bit of a typo here. So let me quick change that. But essentially what we were doing on this problem is trying to decide what the possible values of y are, and they give us some information, okay? They tell us that x is 77, angle of x, oops, I wrote that backwards. X is 70 degrees, 77 is the length of its side, and the length of y is 33. Our job is to find what are the possible values of y. Now, we look, and there's no way to prove this is a right triangle, so we will have to use we can't use SOHCAHTOA. We can use law of sines, though, because, look, x and x, they match up. We have a partner, okay, a pair. So, the sine of 70 divided by 77 equals the sine of, we don't know, so I put a y, divided by 33. Okay, we'll cross multiply and then divide by 77. So if we look at this, we'll do 33 times. Also, make sure you're in degree mode. Double check. I am already in degree mode. If not, you know how to change it. Okay, so 33 times the sine of 70 divided by 77. Now that's not our answer. We then have to hit second sine, second answer to take the inverse of that. We get 23.7 degrees. Now, if we had gotten an error here, that would have told us there was no possible triangle. But we got 23.7 degrees, so that is one of our answers. Now we have to check for a second answer. To do that, remember we always take 180 minus what we got. So these will be supplements to each other. 180 minus 23.7, and if we do that, 156.3. Now, before we can accept that as an answer, we have to double check. Is this possible? If we look here, 156.3, if we would add that to 70, it's going to be greater than 180. That's a problem. That means it's not a possible triangle. So we put no second triangle. And our only answer then is y equals 23.7. So hope you have a great day. Please continue to work on the Delta Math. Remember, our test is Friday. If you've been out a lot, reach out. I'm not going to make you necessarily take it your first day back, but we got to continue to move forward so that we are ready to take it at some point soon. Bye.